motive behind this series is to try and bridge this gap between theory and real-world application, while also creating meaningful mentorship opportunities for students and young professionals as they navigate their academic and professional journeys. So, what can you expect from today's session? In today's session, we'll explore how semiconductors, power intelligence systems, how robotics is transforming industries, and how artificial intelligence is redefining the future of technology. The session will conclude with an interactive Q&A and mentorship-focused discussion, giving you the opportunity to engage directly with our speaker. Okay, ladies and gentlemen, now before we begin, it is my distinct pleasure to introduce our esteemed speaker for today's session, Ms. Gayani Rathnasekara. Ladies and gentlemen, the accolades are many, and I will be doing a great injustice if I were not to mention all of them. A PhD candidate in electrical and computer engineering at Florida International University in the United States, where her research focuses on digital architecture design and signal processing innovations that support next generation wireless communication systems and advanced sensing technologies. Prior to pursuing her doctoral studies, she served as a lecturer at the University of Ruhuna and worked as a project lead at Axiata Digital Labs, where she led the telecom solutions teams. She is also a recipient of the prestigious Women in Spectrum Scholarship 2025 and a participant of the SEED Program 2025, through which she actively contributes to advancements in semiconductor technologies while empowering the next generation in this field. In addition, she serves as the founding secretary of the IEEE Solid State Circuit Society Miami chapter, where she plays a key role in establishing the chapter's vision, fostering professional collaboration, and strengthening engagement within the global semiconductor and integrated circuits community. Ms. Ratnasekara holds an MBA from the Postgraduate Institute of Management, University of Sri Jawaharlandpura, and a BSc in Electrical and Information Engineering from the University of Brunei. Ms. Gaini, it is with immense pleasure that I welcome you as our distinguished speaker for the first episode of the Tech Exchange series. All right, now before we begin the presentation, I'd like to quickly walk you through how today's session will work. During the slides, you can submit your questions in the private chat or open chat on Zoom. After the presentation, we'll have a dedicated Q&A session where Ms. Ratnasekara will answer your questions. Later, a Google form will also be shared for mentoring follow-up. So if you'd like personalized guidance in future, you'll have a chance to submit your interest. With that, I'll hand it over to Ms. Gayani Rathnasekara to begin the session. Over to you, ma'am.
Okay, thank you so much, Hirusha. It was so nice, and you did it very nicely, explaining everything about me. So it saves time. So without
Thanks
taking
a lot,
much
miss.
time, I'll share my screen with you, and let's move on with our presentation today. Can you please confirm whether you can see my screen?
Yes, miss.
Okay, cool. Okay, so as Hirosha mentioned, I'm Gayani Rathnasekara from I would say FIU, Florida International University. So currently I'm doing my PhD. I'm a PhD candidate. And next year will be my starting of the fourth year. And during that time, so I thought what I know about this industry, this field, and the future trends, the technology gap that we have, I thought it's better to share with you all because it's really important to aware you about what is really happening in the industry and what you guys have to have by the end of your bachelor's because we saw there was a gap that we have. So I want to reduce that gap and help you guys to be more competent when you are going to the industry. So with that insight, let's start today. Future tech starts here. Chips, robotics, AI, and the mentorship that you really want to shape your future. So, before starting the session, I want to thank you, the UA University, IEEE branch, and everyone who really wanted to make this event happen. Amidst of this cyclone Ditwa, the effects of everything, but you guys were amazing. Wow, so I'm so happy for that you guys are rebuilding, our country is rebuilding. So that's a very good positive sign that we all are working hard to bring back our Sri Lanka to the best way that we can. So that's a good sign, and thank you so much for you. And I want to give our thoughts to everyone who lost their lives, uh, everyone who lost their loved ones, and for everyone who are struggling to rise back. So we want to give our thoughts and prayers for them. And then let's move on with our session. So let's move on with the first slide. So where does tech starts? So technology, tech, everything we are saying tech. So we'll see where does this start. So we want to know what is really happen. So first of all, please answer this question. How many of you used a device with a chip inside it today? Please raise your hands in the chat. You guys have the option. So how, okay, one is there. Three plus, yeah. 5 plus, yes. If anyone is having their tablet or laptop or mobile phone or even the electronics device, maybe a blender, maybe an oven, if anyone is using such a thing, it's all built up of chip. So yes, that's true that you all are a part of this semiconductor world. Okay, thank you. Now you guys good. No need of raising your hands. So this truth of this world is our entire world is running on top of semiconductors. So that is the place where technology starts. It's the foundation of modern technology. So if any of you have done chemistry in your O levels, A levels, undergrads, then you are part of this ecosystem. So there's no fantasy, no rocket science, nothing. If you have any sort of an insight, if you have heard of carbon, if you have heard of silicon, yeah, you are a part of this modern technology and you are already on it. And the most fantastic thing in here is the global semiconductor industry is thriving. It's a $1 trillion industry right now, and it has a very high shortage of talented individuals. So that's why we want to show you as Sri Lanka, a country which is developing in terms of technology, you guys have a very high responsibility. I do have, you do have, to promote these latest technologies and go with the technology that is happening on real world. Because when I moved to US and when I saw the technology, the equipment that we are using there in US and what we used to have in our university level, there's a huge gap. So by reducing that gap, we can reduce the technology latency and we can move on with the world. You guys can do that, I'm pretty sure, because I have seen there are a lot more people in the industry from Sri Lanka who are leading in Intel, Qualcomm, Apple, like massive companies. There are a lot tech experts from Sri Lanka. That's why I want to show you guys, don't be afraid. This is nothing but you guys can achieve. Okay. So let's go through this and I'll show you what are the opportunities that you guys have and what you guys can do on that. So I want to remind IEEE Semiconductor Education, Empowerment and Industry Development, the SEED program that I am a scholarship winner of that. That is one of an initiative from IEEE Solid State Circuit Society that they are promoting this semiconductor education among underprivileged countries or like unseen countries who are not that much into tech. So this is a good platform. If I will show you at the end, if you guys really want to get involved in that, you guys have a lot of opportunities. So go in that. So this first slide is to give you an ice break about what is really happening in this domain, because it is semiconductor industry is the heartbeat of 21st century. So with that insight, let's move on for a ice break session about semiconductor. What is a semiconductor? Please give me a quick answer in the chat. What is semiconductor? What is a semiconductor? I'll give you 30 seconds. What is a semiconductor? No answers. You hopefully I know you. Everyone knows what a semiconductor is. Anyone? Give it a try. Don't think so complicated. It's a simple question. Electric conductor with zero resistance. What else? Let's see one more answer. Yes, another answer. Has both conductor and insulator properties. Yes, that's a good answer. Material which resistance depends on. Yes, very good. The three answers are really right. Yes, semiconductor is one that act as both a conductor and an insulator, and it is the basic and the essential building block of any electronic device. How it works is upon our or engineers or anyone who uses it, it depends on the person who really wants. If the person wants to flow electrons, like creating a region in positive charge or a negative charge or whatever we say doping, so it depends on the engineer's manipulation. If anyone wants to use it in conductor side or insulator side, whatever, as a switch or anything, it is on us. So that's how a semiconductor works, and that's why we really use semiconductors in all of our electronic devices, because of that flexibility. So the transistors and all the semiconductor devices are highly flexible, and that's why we really use that. With that, let's move on. How are semiconductors made? That's another question. So, have you guys heard about foundries? Foundries. Have you guys ever heard about foundries? TSMC? Sorry for that. Have you guys heard about, please say yes or no, raise hand. Have you guys ever heard about foundries? No. Yes. Yeah. Okay, that's a good thing. So you are really learning something very new, but it's very prominent in the in terms of electronic world. Yes, TSMC. Yes, TSMC is the world largest semiconductor manufacturing company. It is in Taiwan. That's a Taiwan Semiconductor Manufacturing Company. TSMC is the place where more than 60% of world semiconductor chips are made, because it's a very highly technical specialized area where very advanced equipment are used to do this process. So TSMC, more than 60% they cater the global requirement, and in other terms they does more than 90% of the advanced chips that we use all in Apple MacBooks, iPhones, MacBooks, and Samsung, maybe everything. In Samsung also they have about 10%, but they are also outsourced. So foundries are very specialized. Part of semiconductor manufacturers, and they do a really great job, and you guys have a lot of opportunities in there. So once the semiconductor wafer, if we say it's a silicon wafer, it's one of the most common wafers made of like semiconductor sheet that make, we call it as wafer. So there are maybe not only silicon, there may be gallium arsenide, silicon carbide, germanium. Likewise, there are several other as well. So once that wafer is created, it is polished, and it is a very methodical and very advanced process. And then these ICs are placed on it. You can see how tiny, teeny uh, chips we have, right? If we take a iPhone, we know how many parts are controlled with a single little IC or the chip. So that much advancement, like, it is incredible. That process is amazing. And if you really guys want to be a part of that rigorous process, yes, you guys have that what not have that opportunity to join these companies. So you guys can build whatever the background foundation that you guys want to go to get involved with these industries, and you guys can go a long path with this. So why semiconductor benefits is because of its size. The weight is very less, they are so efficient, they are very flexible, they process very fast, and we can customize it accordingly, whatever the way that we really want. So, and also, once we know about semiconductors, giving you guys all some sort of a ice break session. So, you guys have to keep in your mind, when you guys are going to this industry, there are some other laws that you guys want to know. For example, Moore's law. Moore's law is not a physics law, it's an economics law, because it says about doubling the transistors on a chip every 2 years. So it's economical uh, derivation, a law. And then Amdahl's law of mass action, and there are likewise laws related to this semiconductor field. So it is better if you guys have some sort of an idea or a hearing or knowledge about what is happening in this semiconductor ecosystem. That will help you guys drive in the tech world where you guys really want to try. So by the end of these few 10 minutes, you guys got to know what is a semiconductor, how do they work, how it is made, and the benefits and the laws related to that. That means you guys now know about semiconductor fundamentals. So that is the baseline. So why I really wanted you guys to have this understanding is because it really helps you to know what you guys are going to do at the end. Because if you guys don't know what you guys are really doing, that's the problem. So anything when you guys are learning, try to have ice break on high level, that what you have to learn. So then you guys have a picture, high level picture about what you guys are doing, and then you guys can focus on what you guys really want to do. So that's why I really wanted to show you. And now let's see, what are these solid state circuits? So what is an IC? I don't ask it again. You guys all know. IC is millions and billions of tiny semiconductor devices fabricated on a single chip, single piece of silicon, or a single piece of gallium arsenide. Likewise, any of the semiconductor where we implant ICs and other relevant semiconductor devices. And then how a solid state circuit is designed is, it is nothing but an IC on a PCB. It is very simple. So you think simple, then you guys will learn what we can apply it and where we can really apply it. So in terms of ICs, or in terms of microchips, or the chips, we also say chips. So there are different types of chips. There are analog chips, digital chips, mixed signal ICs, power ICs, RFICs, SOCs, lot more there. So if any one of you guys want to specialize in analog domain or digital domain or mixed signal domain or RF domain, you guys have a lot of paths to go, and I will show you what are the paths that you guys can pick and decide what you really want to pursue. Okay, with that, let's move on. So it is nothing but everything is solid state circuits. Okay, so there's an interesting or fascinating engineering process of designing microchips, because when I'm saying technology is coming from these. So it's better you guys have an understanding of how these fascinating industrial marvels are made. So with some piece of sand, silicon, that sand dust, how we can create a chip, a very sophisticated, fantastic chip. It has a rigorous process. First, the raw material, this dust, will be there, and then there's another UV light 3D pattern drawing on the wafers sort of a thing is happening, that is called photolithography. And then there is a process of etching and ion implantation, then layering. In layering, what it happens is it's mounting all the chips or the semiconductor devices that you really want to have in the chip layer by layer. And then these all four process happens maybe at a one place, maybe in different companies, and then for inspection and testing and packaging, that can be sent to another company or can be done in the same company. And for distribution and integration, there can be another company or the same company. So it's a this all six steps may be done in one place, may be done in several places. So in each of these steps, you guys have a lot of job opportunities, lot of technology, lot of knowledge. Like it's a it's a fascinating ecosystem. I will show you what are the opportunities you guys have, and then you can decide whether you will be a design engineer, whether you will be a verification engineer, whether you will be a software engineer, whether you will be a packaging engineer. Like that, you guys have a lot of pathways. So you don't want to know all the thing, everything, but you guys have to know specific thing to the depth and high level understanding about what is happening in the other steps as well. So far, if you guys have any questions, drop a message in the chat, or you can ask at the end. So we were coming from the tech, so everything was fine. But everyone is talking, so chip manufacturing is like magic mixed with engineering. Okay. So everyone is nowadays talking about AI. So I think you guys also may be curious how how this tech and AI, how this semiconductor and AI, how this blend. It is a very interesting topic actually, because we can't say semiconductor is number one, AI is number one, because it has like a cyclic path, both parts. Semiconductors have a role on AI and AI has a role on semiconductor. It's like that. Because if you think AI is a software thing, right? So AI can't breathe without hardware. Hardware is built with semiconductors. Okay? So without hardware, no AI. In the other way, in order to optimize the functionalities of the semiconductor hardware manufacturing stuff, we and everyone is now using AI. So for the betterment of semiconductors, you need AI. For the betterment of AI, you need semiconductors. So AI is never replacing semiconductor engineers. AI is increasing the demand for them. If someone is capable of handling both AI and hardware, that one will be the most demanded person in this field, because that is the requirement in the current field. Because you guys know, now we are sometimes we are complaining that my processor is very slow, I can't process even this AI model in my laptop. Why? Because hardware is not compatible. So now what they are doing is, what the industry is doing, they are making hardware compatible to process those high AI compatible software. So if a person knows how the hardware works, and if a person knows how AI works, and if that person can blend this together and give out the solution, that is the requirement of the industry, that is the need. Okay, so we as engineers, we want to understand the devices, circuits, architectures in terms of hardware, as well as how we can utilize in intelligent computation, how we can use these GPUs, TPUs, and make the processes function more sophisticated. That is the requirement. So AI is the brain, but semiconductors are the nervous system that makes intelligence a real. So that's how semiconductors and AI blends up together. And if I ask you a question, now I'm asking you, we are moving to career pathways, so where you guys are really keen on learning about what this having in this whole conversation. If I ask you a question, should I focus on AI or hardware? What is your answer right now? Please give your answers in the chat. Both, okay. One says both. I think everyone's answer would be both. Yes, that is both. Because now the future all engineers' expectations are who can work in both AI and hardware. Not specifically AI, not specifically hardware. Even in medicine, you need AI knowledge. So just having AI knowledge will not work in any of the field. Any of the field. You can go further with if you have AI knowledge, but you can't just go with just having the knowledge on AI. So you want to know how to apply it on specific fields. So semiconductor industry is one of most demanding, massive uh, talent required industry, fast growing and highest paying. And the companies are really having lack of engineers in US, in Europe, in Asia, any continent. So what careers you guys really want to have? So IC design, as I explained you earlier. In IC, I told you there are analog, digital, RF, mixed signal, there are a lot. Not only IC design, okay? Semiconductor device engineering. IC designing is just one segment. Semiconductor device engineering is another. So you guys have that opportunity. And in terms of verification and validation, chip testing, embedded systems, fabrication, packaging, EDA software, the software that you really want to have this, you guys have opportunities over there. Then the hardware security, software security, machine learning. All these are the career pathways that you guys have in the future. So we'll step one little by little and see what are the things you guys want to really want. So if I summarize high impact career paths, ASIC design, PCB hardware, embedded systems, device fabrication, material science, all these are very high impactful career pathways that you guys can go for. And now you might be thinking, okay, then what should I really want to have? What are the technical expertise I want to have if I want to go into this? So that is one of the main question that you might have. And how can I start with? It's another question. So I'm combining all the mentoring and both together, and I'm doing this. So by the end of the session, you guys have a profound understanding about this whole tech process. So I'll explain you what are the technical foundations or the courses that you really want to have and what else you can do to further learn about this. Okay. In terms of technical foundation, I would say electronics is a must. It You may be electrical engineer, like you may be doing an electrical degree, you may be doing a telecommunication degree, you may be doing mechatronics, you may be doing electronics, whatever it is. You guys have to have fundamentals of electronics, digital electronics and digital logic gates, basic RF concepts, analog circuits, semiconductor basics, like electrical and electronic measurements. Like those electronics fundamentals you have to cover whatever field you are, robotics, electrical, whatever that you are following right now, it's fine, but you must have good basics about electronics, because that is the underlying whatever. So the semiconductors are the underlying foundation for all technological advancement. So you having this fundamental knowledge is the best thing that you guys have for your entire career. So have it first. So read it. If you have forget it, just revise it. It's true that we forget the stuff, but it's fine. Just revise when you forget. Okay. And programming. In terms of programming, I can't explicitly say you must know Python, you must know MATLAB, you must know Verilog. It depends. It depends on the field that you guys really want to go. So you guys don't want to know everything. If you are so interested in validation like stuff, then you guys might need Verilog, Python, MATLAB like stuff. If you guys really want to do hardware developments, then you might need C, C++ more. So it depends on the role that you want to really play. Okay. So what you want to have is have an understanding of all these, and depending on the role that you guys want to go in, specialize on that. Okay. So, and then in terms of EDA and simulation tools, Cadence you have like Cadence you have for both digital IC and analog IC design, then Synopsys, then Xilinx Vivado to our tier to GDS file creations, and then in terms of RF side you have Keysight ADS and AWR. So LT Spice, likewise, there are a lot of EDA tools that you can be familiar. So but don't be afraid. You don't need everything to know. What you need is one area that you like to pursue and then basics of about others. Okay, that's the most important thing. If you are saying, I don't know about everything, I don't know, that's fine. Just know one thing to the depth and others in the basic level. That is totally agreed in the industry as well. Okay. Okay. So having said this, how you guys can learn? You don't want need to worry like I haven't done this. It's fine. Start now. It start right now. You can revise your previous lecture notes. You can do free online courses. You can do by yourself some simple hands-on projects like synchronous 5.4. Try to write RTL code. Okay, just be familiar. Maybe you're a robotics engineer, maybe you're a mechatronics engineer, you may be electronics, whatever. But try to have this, because these are simple things that you can add in your resume and you can tell that I did by myself. That's what industry really need. Someone someone who's thriving by themselves individually, because then that will help you group learning approaches. So try to do group projects if you can, and try to involve in the university programs, try to involve in IEEE competitions, volunteering opportunities. These all will build your ecosystem. These all will help you guys to improve your technical knowledge as well as social skills. So balance in both will help you guys to have a good industrial exposure in the future. Okay. And then I thought of sharing with you some information about semiconductor companies. So the reason why, so most of you guys may be going for internships during your undergrad period. So when you are picking your undergrad internship, it really matters if you guys have a clear proper path. So in terms of global semiconductor companies, because semiconductor companies means that it's a very expand ecosystem because it has different segments. So if you're in terms of going for design and devices, you have top companies like Intel, AMD, Nvidia, Qualcomm, Apple, like that. And if you are going in terms of EDA tools, the software tools, then you have Cadence, Synopsys, like that. And then in terms of AI hardware and the startups related to that, you have ARM. And if you go for photonics, there are other. If you go for quantum, there are a lot more other new startups. Okay, so go and see those. I'm just putting some of these in here because I just want to show you guys what are the things available in the global market, what are the leading companies in the global communities. And if we come to regional and remote, like in Sri Lanka and Indian subcontinent areas, in Sri Lanka, I saw this, I found in Google. SGS, one of the Swedish companies, then Paracom Technologies, ABB, TOS Lanka, it's from Tokyo, Tronic Sri Lanka, Synopsys, we all know, Fuji Electronics, those are some of the top Sri Lankan semiconductor companies that are going beyond miles in this very recent time. So that's a good sign that our technological literacy is increasing. So that's a good sign. And there are some other companies. India is one of the top tech people live in in terms of country and even in all world. Like there are a lot more Indians in US, in UK, everywhere who are tech giants. So they do have these top companies, global top companies in India, like Intel India, Qualcomm, Samsung, Synopsys, Cadence. So if any of you have a mission or a vision to go for an internship in this sort of top companies, you guys can try applying for internships in India. For sure, you will get. So build your tech, the things that I asked you to improve in the previous slide, and then you guys can apply to these companies by the time when you guys are applying for internship. Okay, so build your background so that by the time when you are finishing your third year, when you are finishing like maybe 5 6 semesters, when you are getting ready for the internships, you guys have a full bucket. You guys can go for the internships. Okay, so opportunities are there for you. You guys have to go for it. Okay, so this is some picture in a picture format. What are the things that you guys have in terms of design, manufacturing, equipment, testing, manufacturers again, like different companies. You have lot opportunities and they are really requiring top talent. So you guys, if you build your potentials on these sites, you guys have the opportunity to go. Okay. And with that understanding about the whole semiconductor technological ecosystems expand all over the world, we'll move on to how we see Sri Lanka and tech. Why we matter, why you guys matter. So now we have to get out from the mind that we think that high tech is something not for our like countries. It's only for big countries to do. No, that is no. Because Sri Lankans are already contributing in chip designing, AI research, robotics, electronics, embedded systems. They do wonders. So you guys are part of it. I'm a part of it. So we guys can do it. So we can do it in our generation. So we have to build our mindset on an innovation, and it's not making everything perfect, but it's built upon curiosity, consistency, courage, and we guys want to like do it. Okay, it's not a easy process. It's a very uh what say courageous process. So yes, behind every cheap product are countless failures, wrong designs, broken circuits, unexpected bugs, but it's all right. Still, if you don't stop and if you guys do it, if you guys continue to do that, that's the success. Because all these innovations built on this world are built upon failures. Very simple example that we all know, Thomas Alva Edison, how many times he attempted to build the bulb, right? So why can't we fail and why can't we be successful one day, right? So don't worry for failure. Don't just go for like instant sparks. It will take time, but go for it. Do continue. These works are amazing, but it all needs time. It's okay. You guys have time. Go for it. Okay, that's what I really wanted to say, because you all know, you all have done chemistry, you all have done physics, you all have done mathematics, you all have that basic knowledge. So it's your patience, it's your consistency, it's your motivation to thrive and go for it. Okay, so don't left behind like, oh, my design looks bad, it failed, it's not running properly, it takes a lot of time. It's fine. At the end you will see, oh, I did it. I didn't sleep for days, I didn't eat for hours, but it's okay. Everything needs that, but sacrifice, I would say. So there's nothing like coming with perfect for the first time. First, you have to try. Trying is the best thing, okay? So you all guys, because now you saw from Cyclone Ditwa, you all got affected. But see now, even within 2 3 weeks, you guys are again back and you are again into academics. You are again learning because you have that energy. So think the same way. You guys can exceed the expectations of this technological era and you guys can do that. So take every challenge as a very good positive thing and do it. Okay, but do it in a very methodical way, like learn with like a purpose. Know why you are learning that. If you really know why you are learning this section, and if you feel like this is not my domain, it's fine, change your path. It's okay, but do it mindfully. Do it mindfully. That's what I really want to say. Okay. So fields your background perfectly fits, maybe electronics engineering, maybe chip designing, maybe robotics, maybe mechatronics, maybe renewable energy. It may be vary, but it's you. So pick the path that you really want, and you maybe you can't decide it today. It's also fine. You don't need to decide it today. Everything by today. Okay. So this is just to give you an understanding about what's happening. And it's your responsibility later to go and see whether this fits you. It might fit, it might not fit. So it's your chance to go to explore and have an understanding, because now as undergrads you have some time for that. So take your time, explore what you really want, and identify your weaknesses. Do a SWOT analysis, strengths, weaknesses, opportunities, and threats. Do a SWOT analysis for yourself and try to find the weaknesses you have, the strengths you have, and with that, try to build a career picture for you in the future. Like in by the time of graduation, I will be like this. Have a mind that having a mind map on you for you will be really beneficial for you one day when you are going maybe to the industry, maybe as a lecturer or anything. Okay. So what is one? Okay. This is a good question after all these inspiring talks. I'll give you 30 seconds. What is one technology problem in Sri Lanka you wish you could solve? Okay, I'll give you 30 seconds. Please give me your answer. what sort of a question that you can solve in the future. Maybe by yourself, maybe with the team. It's fine. Because you guys are all in mechatronics, electronics, all good engineering domains. So give me a please type on the chat. What is one technology problem in Sri Lanka you wish you could solve? We'll see the interesting answers. It's fine, you can directly message me. No need to put on the whole chat. You can just directly send me an answer. It would be better. So, because sometimes they don't like to share with everyone, so it's fine. Just send me. Okay, I'm getting some answers. Good. Because try to build your question Q&A mindset, because that will really help you to build something good in the future. Maybe to be an entrepreneur, maybe to be a businessman, maybe to be a CTO. You guys want to have that understanding of the questions and what sort of answers I will build on. Strategic thinking is also one of the main things that you guys have to build as engineers. Okay, so I'll wait for another few seconds. Because with the current situation that we all faced, you guys knows things that we really need to have some technological intervening in our system. I will give you an example as well after these few seconds. Okay, so let's finish it for now. Yes, they are automating the transport systems, online tracking system, weather prediction systems. Yes, yes, we really need in Sri Lanka. We really need. If I give you an example, in USA is a country with 51 states, right? It's a very huge. But all states are governed separately. And in each state, for example, Florida, where I'm in, we have hurricane season. It's not like Cyclone Ditwa. It's way massive than this. Okay? But they have a very good predicting systems. They forecast it very early, like before 3-4 months, and they announce every region where it will have an effect, and they provide all the details of evacuation, what the things that we have to have, everything. So the human damage, the physical damage will be very minimal by the time. So that high, so they are tracking the nature and they are utilizing in the best way to safeguard human and animal lives. So those sort of technological intervening is really required when we are living in current world with the sophisticated lifestyles. Okay, so that they have the process there, they have the system there. So we too have to have a system in Sri Lanka, so we can have a good technological intervene proper system with the good education and go- um government or governing stuff we have to have. So you guys are the future. We guys are, I'm also part of future. So we guys have that responsibility. Okay. That's a heads up. Okay. Okay. Now I'm moving to the last part of this session. This is how you guys can build your undergrad period more efficient. how you guys can build your network, build your social skills, build your technical expertise, everything through IEEE. This is something inspiring for you all. So Solid State Circuit Society, which is called SSCS, is one of the most best platforms for you guys to can involve during your undergrad. So this is SSCS collaborations across IEEE. So they have connections with sensors, biometrics, nano, RFID, even CAS. There are a lot more other. So these are some of them. And these are the prestigious conferences that you guys can involve if you really like to join on. Then you have direct latest access to the world technologies. Okay, and you have free access to these all publications. I will share you why I'm sharing this, and this is one of the most important things: technical and career development resources. Everyone can access SSCS YouTube channel, which is more accurate and reliable source of information. Go learn from there. There are more content about from IC design to many related to the semiconductor uh, field. So go learn from there. And if you are a SSCS member, then you have a lot more stuff access a resource center. So this is only for SSCS members. And if you can get the membership, better to take it, because it's a good way of learning correct, right, most advanced things. Okay, so how you guys can get the membership, I will tell you. And if you want to join, participate, and volunteer, even in this regional conferences in India, there are a lot more conferences going. So you not only in India, in Singapore, so there are going. So if you guys really want to join, go apply for these volunteering opportunities and get the best benefit since you are in your undergrads. Okay, you guys, I don't say you guys have time, but you can manage your time. Okay, so if you want free IEEE and free SSCS membership, there also you have another chance. So if you can do tutoring for 5 hours, not continuous 5 hours, any 5 hours, then you guys have the opportunity to get free IEEE and free SSCS membership as well. So if you need any information about this, I will tell you it separately, because this is not a IEEE promotion uh, session. This is just to give you heads up to show you the opportunities out there for you. There are a lot of opportunities out there for you, so get the benefit out of it. That's what I really want to highlight here. And yeah, last but not least, the discussion. The tech exchange that we had today is everything about the latest modern technologies that built from semiconductors to chips to everything that you guys are really into in this modern world. You can't survive without a smartphone right now. So you are a part of this ecosystem. So, and the most interesting and fascinating things, you are building this stuff one day because you are in this domain. So you will be the ones who will create the future. So that's so interesting. So in you will be in a part of these emerging domains of AI chips, quantum, green ICs, shaping the next era of technology. So we guys have a responsibility on it, and I think with your good academic excellence, you can have very very inspiring future with this. So go it on a nice way, in a methodical way, so you guys can lead to very nice destinations. I really want to highlight this is because when we graduate, me when I was graduating, I didn't have much literacy about the or the awareness about the electronics job opportunities in the field. So most of us changed our career pathways to maybe software engineering, maybe to telecommunication engineering, like that. But now you guys, now I see, no, there are a lot more electronic job opportunities also in Sri Lanka, even in outside. You guys can apply for that. So go for it, apply for it, and get the opportunities. That's the most important thing. Okay, so technology can change your life, but your mindset will shape your future. Start now, start small, stay curious, and remember, you are capable of more than you imagine. If I'm here today, you will be in a very better place, I'm pretty sure. So go for it. That willpower I want to share with you. And this is not just a talk, okay? This is the beginning of our everyone's of our movement. So you're the next generation of thinkers, dreamers, engineers, researchers, and the leaders. Okay, you guys can start now and go step by step. So if you guys need any further information, maybe about your academics, maybe about your careers, maybe how we can shape, what are the things that we want to learn, I'm here to help you. If you have any questions, you can just privately chat with me, or you can, for now, you can just send me a chat. And then, if you need any information further, you can, this is my LinkedIn profile. You can just send me a request and send me whatever the question that you have. I'm always happy to help you all, any one of the students who are working, because I was a lecturer before I was going for higher studies. So I did mentoring for a lot of students, and I do understand. I'm also a student still, so I know how it happens and what are the difficulties that we really have, and what are the things that we have to break out, and where we have to go. So I'm always happy to help you all. So please feel free to ask any question you have. If I don't know the answer, probably I will guide you to the best destination that you want to go and have that. Okay, I trust on that. Okay, so that's the end of the session. So please feel free to ask any questions you have, and we'll move on.
Miss Ratnasekara, thank you
Yes.
so much for the passion for the development and change in the electronic sector. It's truly evident. Now, as you said, let's move on to the next session, which is a Q&A session. If anybody got any questions to ask right now, we will be facilitating it. And yes, we got our first question, Miss. Over to you.
Okay, I'm getting some questions. I will start. In the meantime, you can just put the question. I will answer you. For now, for this first question, for students from countries like Sri Lanka, how common are remote research internships in semiconductors or AI, and in which roles are they realistically possible? Should a platform like LinkedIn be used for it to find personal contacts, or should we apply an official website? Yeah, that's a good question. Uh, there are some restrictions in some countries, because in terms of this technology related domains, but it is mainly related to maybe defense or security affairs, like that. In such cases, they don't allow outsiders or outside people or non-citizen people to work in their companies. So there are some restrictions like that, but there are some job roles that they are open to anyone. Maybe it is remote. Now remote jobs are very less, but there are some as well. So you guys can use LinkedIn or the official website, because the reason, for networking, that is fine, use LinkedIn is fine for networking, but always don't go with job posts in LinkedIn, because in LinkedIn also there are some fake stuff now. So better to go to their official website and see the internship job roles that you can have, and then you can apply from the official website. In the meantime, if you want to know who are the people in LinkedIn, then you can use LinkedIn and go to find the people and have a friend request and get to know about them. But don't always go by the job post in LinkedIn, because now I find sometimes there are some fake stuff as well. Okay, so that's the first question, that's a good one, because now with the technology, you guys have to be very concerned about that as well. Like the trust, the reliability, is that fake or is that true? There's a big question there. So better to go with the official website if you are applying. I think that's a good practice. Okay. And Miss, how important is projects I'm planning to follow up with power electronics side? Should I focus on research or the projects? It really depends on your passion. If you like to be a researcher, it's better for you to do research and to have some connection with the professor or a lecturer and do some publications. Okay, if you are really happy to do a research sort of a career, if you like to get involved with the industry and research, if you don't really know what to pick, whether I'm to be a researcher or whether I'm to be an engineer, then the middle path is doing projects is fine. You guys can do the projects with the professor and then you can do the publications as well. In that sense, you guys have qualifications for both. Qualifications in the sense the skills for both. If you, so by the end of your undergrads, if you feel I'm not okay for research, I'm going for industry, then that's also fine, because you have done projects and you have that hands-on experience. And if you at the by the end of the undergrads, if you think I want to be a researcher, that's also fine. You have done research and you have that hands-on experience, so you have done publications. That's also good. So I can't give you exact fine answer. You have to do research first, do projects. No, I can't say like that. Research research means is also some sort of a doing projects, because when you are doing projects, you have to have an understanding, do a feasibility study. You want to know what's currently happening, what are the experiments that are using now, and how you can use your innovation or the discussion that you had with your professor or someone, the insights from that person to use in here and apply here and build a new solution. So doing a project is also some sort of a research, but may try to implement it. Like if that's a theory, you can't 100% implement and show, but if you can show the application of it, the applicability of it, and how you can use it in the real industry, that's the most important part. Try to see the usability of it and try to highlight that. Then that will be the most important part. It can be in any domain, maybe power electronics, maybe robotics, maybe mechatronics, any domain that you are in. Try to see the usability and applicability in the modern world. That is the most important thing. Okay. The other question, what's like a common gap that students will face when they start out in the industry that is not sufficiently covered in the academic sides of things? Okay. I will talk first with my experience and I will share with you what I saw in as common. Okay. What I found is when we were going to the industry, sometimes I felt I'm using nothing what I learned from my undergrads. Okay. It's a very common thing, because it's a very common thing. I even heard from my friends. Now I learned for 4 years, but now I'm applying nothing what I learned for the 4 years. That's a very common thing. But that's not 100% true. That's not 100% true. Some or the other way, we are using some things knowingly and unknowingly. Okay. So what I would say is better to have the basics. If you are going for the electronics domain, have the basics electronic knowledge. If you are going for telco, have telco basics. So that you guys can apply it in anywhere in using any software, because technologies are advancing, but the basics are the same. Softwares are evolving, but the software basics are the same. Versioning will upgrade, but the basic knowledge that you have is the same. So try to have the basic knowledge, and when you are going to like graduate in like you have think you have around 6 months of time, try to see what is really happening around. What is the latest technologies they are using? Maybe so. If you are targeting Sri Lanka, try to see what is really used in Sri Lankan domain. It may be not what you we are using in USA. Maybe not what we are using in UK. Try to address the things that you are going to do in your domain. If it is Sri Lanka, try to see what is really happening in Sri Lanka. So, for example, now in Sri Lanka, still we are working on 4G, right? Not in 5G. But if you are going to a industry and you are applying for a country in US or like UK or somewhere, you can't go with 4G knowledge. You have to know the understanding about 5G, the layers in 5G, what are the hardware used in 5G. Okay, so likewise, try to balance, have a balance with what where you are going to focus. Okay, and the other question, Miss, if you were to redo your undergrad project, which topics would you choose? Now that you know the master's fields, what can we do to have a better chance in scholarships? Okay, this is a very, how would say, if I'm not, I won't say I will redo my undergrad project. My undergrad project was the best project. Uh, in our undergrads, we designed a low-cost, eco-friendly PCB prototyping machine. It won the like best project award. It's a good project because we wanted to really have something we can manufacture by ourselves and give to the market without purchasing from outside. But I see after we developed, there was no path of commercializing it. I find that gap there because after, though we got the best price, it was not commercialized. So I find the gap between this academic research coming into the industry. So we have to have a good path connection in between that. So that's the one thing. So I won't go for redoing undergrad project, but what I suggest you for better scholarships and stuff is like go for green, like if you are into more into electronics, IC design, like that, have try to develop more efficient fast processing processors. That would be better if you can develop a architecture, if you can propose a power efficient mechanism like that, that would be good. And even analog ICs, if you can design very high optimized uh, mainly power efficiency and parallel processing, fast parallel processing. Those things are in terms of chips and processors. And eco-friendly methods, whatever the may be. If you are in electrical domain, try to go for more renewable options that we can really practically use, because there are some issues when we are using renewable energy sources. So there should be some things or some innovation there. So try to address those, try to master those. So I can't specifically say you have to master this one field, but try to have a balance with the latest technology with AI, and I can't say specifically quantum. So it depends on what you really like to do, and what are the opportunities that you have in the university also sometimes matter. So try to see the infrastructure that have in your labs, because that also matters. If you really like to do something very great, and if you are limited by the facilities that you have, then it will be very challenging for you to go on. So try to see what your really requirement in terms of chip designing or robotics or the applications of AI on there. And it depends. So discuss with your professors. Go to every professor and see what they are really doing, and see whether that matches with your passion. Have a good conversation with your professors or whatever your mentors that you have in terms of going for undergrad final projects. then it will really help you guys to shape your undergrad project. I think that would be good. Okay. Okay. There's another. If you were to redo your undergrad project, which topics would you choose? Yeah, the same answer I would say. And there's another. Is IEEE volunteering really matters after graduating? What do we really get? Is it the networking that we make? How to get the most of the membership that we pay? Yes. So in this, I would say once you graduate, you will be a young professional. You will be like YP. So in terms of YP, there are a lot of global networking platforms. So it will help you guys to improve as an industrial profession. You can, for networking and to go for conferences in different countries like that, to expand your knowledge, your opportunities, the circle that you have, it will be increase massively. And if you are to go for academics, if you are going for higher studies, if you are going for you will be getting more opportunities to publish your work. So by publishing the work, you guys will have the opportunity to attend a lot of conferences. You will meet industrial giants, you will meet academic giants. There are a lot more opportunities you there. So for example, in this couple of years, I think in during US, I think I have traveled like 5, 6 international conferences. So it's a very good opportunity. But when I really didn't know once we graduate from after bachelor's until I restart with IEEE after coming to US. I thought when we are in the industry, we really don't need IEEE, but that is not the case. Now I see there are a lot of tech conferences going in Sri Lanka with YP as well. So get involved in them. Build the network. It helps your professional career as well as academic career both. There are a lot opportunities. So try to have volunteering and get they have some badges and some stuff, so you it's a good thing for you to have a good relationships with people. I think that's a very good thing. Okay, another question. What potential do you see in quantum engineering in future, and will there be any commercial applications? Yeah, that's a very good question, Vihanga. Yes, there's a very big potential in quantum engineering, and in terms of commercial applications, I don't see much right now, because even so I met Dr. Keith Bowman. He's a principal architect in SOC team in Qualcomm. I met him very recently, and what he also said was they are using it for research but not for commercial applications still, because it's also like AI. Because a decade ago, AI was also in terms of research side. It was not into this much of application, commercial applications. But see now, after 10 years, even less than 10 years, now AI is applied in everywhere, in every domain. So quantum also may be like that. I can't give an exact answer, but that is that is why this technology is advancing too much. Everywhere there are research going on with quantum. So in a decade, probably what we are seeing today may be changed. So it has potential. Okay, if we publish in a Q3 journal, would have a negative effect, because publishing in Q1 and Q2 is hard. Just wanted to know, Miss. Yes. Yes. What I recommend is publishing is really hard in a top journal. But if you have IEEE membership, try to publish in a IEEE journal paper, because IEEE journal papers are highly internationally, globally, they are recommended. So IEEE is one of the most best platforms that you guys can publish. You have Nature. Nature is also hard, not little, it's hard. Nature is also hard. ACM is hard. IEEE is hard. But at least try to have a publication in IEEE because quality of the journal also really matters. Rather having 10 publications in non reputed journal versus having one publication in a reputed journal really matters. So try to have publish your work in reputed whatever the conferences and journals. Yes. As you are in both IET and IEEE, which would be more useful for us as an undergraduate for the future and also to publishing, which will be good. Yes, I was in both IET and IEEE when I was doing undergrads, but now I'm mostly in IEEE, not in IET. I haven't done much on IET in recent past. So what I would suggest is both are fine because both are globally reputed to um institutes for engineers, and IEEE is more significant for electrical and electronic advancement. That's why I'm more into IEEE. So it is more specific for us, for electrical, electronic, mechatronics, robotics, whatever the advancement in our elect domain is for IEEE. So I'm more into that. So I think in my aspect for us, it would be better because it has good platforms for publishing as well. They have a lot of conferences, they have tech conferences, webinars, journals, so in every domain. So IEEE would be better, but IIT also fine because I personally know a lot of IIT, even IIT, this lecture I know. So they are doing great job. So IIT also fine, but now I'm not much involved to IIT, but I'm working more with IEEE. Yes, so IEEE publishing is well reputed, so well accepted. So in terms of publishing, IEEE is also good. So I would say IEEE is better. So I think yes, for now I think we can conclude our session with this. If you have any more questions, yes, Ravi Sara has shared this Google form. If you guys have any questions, please raise with that, or you can send me a request in LinkedIn and you can ask whatever the question you have there. I'm always happy to help you. And yes, I think that's good to conclude our session for today. Hirusha?
Yes, Miss. Again, as we come to the close of today's session, uh, on behalf of TechXChange, I extend our sincere appreciation to Miss Gayani Rathnasekara for sharing her insights, experiences, and guidance with us. Miss, it's to conduct and convey industry trends and data about the mentioned theme requires great skill in itself, but the way you catered it towards us as undergraduates should be truly commended. I'm sure there are many electrical engineering students here, and as one myself, I truly can't commend you enough on all the different aspects you went so in depth on. From the trends present in the semiconductor industry, the technology behind it, to the advice on internships, I can't stress enough on the doors you opened for everyone here. And as I mentioned in the introduction, the main motive behind this Tech Talk series is to bridge the gap between academics and the industry. And not only did you focus on it, but you actually delved deep into it. And we couldn't have asked for a better suited presenter for our first inaugural episode. The passion you have for change in the industry is truly evident. And we are truly thankful and grateful for your presence. So can I please also, yes, due to the virtual nature of this session, to give a proper token of appreciation might not be possible. But please, I would kindly like to invite all the participants to drop a reaction on your profile or a thank you message in the chat. Please do so. And we truly do appreciate you, Miss.
Okay,
All
thank
right.
you, thank you, thank you very
Okay.
much. Yeah. Let's keep in touch. If you have any questions in the future, please anytime reach to me.
Definitely. Yes, as Miss mentioned earlier, please do remember for all the participants here, please do remember to check the Google form shared in the chat if you'd like to connect with Miss Gaini and engage in further mentorship, or if there's any follow-up questions, that you would have had and you couldn't ask, please fill the Google form and keep in touch with her. So, yeah, that's about it. And to all our participants, thank you for being part of this inaugural Tech Exchange session. Your engagement and curiosity are what makes conversations like this meaningful. Once again, thank you, Ms. Gayani. Your time is truly valuable for us, and we couldn't have asked for a better presenter. We look forward to welcoming you to future episodes of Tech Exchange as we continue exploring the technologies and ideas shaping tomorrow. Until then, stay curious, keep learning, and keep pushing boundaries.